Hello, in this video we are going to look at the different situations we may encounter when we try to intersect planes. Let's consider first the case where we try to intersect two planes. In this case, we have three options. One of them will be that actually the planes that we are trying to intersect coincide. So then here I have my my yellow plane and my green plane, and they are actually the same. So pi1 equals pi2. So yeah, then we have infinitely many solutions of the points of the plane. It could also be that the two planes that we are trying to intersect are actually parallel. Then we won't have any point of intersection. Here we have, say, pi1 and pi2, and pi1 is parallel to pi2. If this is not the case, then the planes that we have will intersect, as we see maybe in this picture, if you can see it. I have my green plane over here and the yellow one, and they intersect on a line over here. So pi1, when intersected with the plane pi2, is equal to a line. In terms of equations, the cases we will have over here, well, the first one will be like we have two equations that are actually the same. Like, for instance, imagine if I have x plus y plus z is equal to 10 for one of my equations, and then for the other one, 2x plus 2y plus 2z is equal to 20. Then actually we have the same plane two times. In the second case, we will have that the vector that is normal to the plane, all those vectors are actually parallel. So it could look like something like this, that we say, for instance, x plus y plus z is equal to 10 for one of them, and then x plus y plus z is equal to 15 for the other. So there is no point of intersection. The vectors that are normal are parallel, but the planes do not intersect because they are parallel. In the third case, we will have, again, I'm just gonna be lazy and keep my first equation to be the same, and then the second one is a plane that is not parallel to this one. So when we try to intersect, the solution set will be the line L. So these just are some made-up examples for you to see what is happening in each of the cases. And this was when we were trying to intersect two planes. Now we want to see what happens when we try to intersect three planes. When we try to intersect three planes, we can run into one of the following each situations. First of all, I'm going to look at the cases where at least two of the planes coincide. So my planes are going to be green, yellow, and sky blue. And let's say that the first case will be that actually the three planes that we are trying to intersect are the same. Pi1 is equal to pi2 is equal to pi3. The second case will be that two of them are actually the same, so two of them are coincident, and then the third one actually intersect them. So let's say we have yellow and green one with coinciding, and then we have the sky blue one intersecting them at a line. So here we have pi1 is equal to pi2, and then we have a third plane, pi3, that intersects the other two. The third case will be that two of them coincide and the third one is parallel to them. So let's say, for instance, we have the sky blue and then we have the yellow and the green to coincide. So I'm saying pi1 is equal to pi2, and then I have pi3 and pi1 is parallel to pi3. So this will be the cases where at least two of them coincide. Let's now move on when we have at least two of them to be parallel without being the case that we just mentioned. So if two are parallel and none of them are coincident, we will have the case that actually the three of them are parallel and none of them coincides. So So like this, over here we have our planes pi1, pi2, and pi3 parallel to each other, but they are different. We can also have that two of them are parallel, and then the third one that we have is intersecting them. So let's say it like this. So we will have that intersects the sky blue one intersects the yellow one at a line and intersects the blue one at a line that is here. So pi1, pi2, pi3, and we have pi1 intersects the other two, which are parallel. I promise 8 cases, so here they come the last 3. We could have the case where the 3 of them intersect at a line. Let's see if I can make a more or less decent sketch of what is happening here. I like to imagine that you are opening a book and you're looking at the pages of the book, and then you see where the pages join. That's a line where they intersect. So all meet in a common line. Let's call that line L. We could also have the case that actually they all meet at a point. So we can have we're going to start the picture the same with the first 2 planes intersecting at a line. But now let's change the third one so that the third one, here we have the line where the first 2 cut, so that the third one cuts the line only at one point. So I'll make it something like this. So then the point of intersection will be the point of intersection of the line and the sky blue point plane. So here we have all meet at one point. And the last case that we are going to have, let's see if I can draw it. Let's say I'll start with the first plane over here, and then I'm gonna make the other 2 planes intersect this plane at 2 different parallel lines. So here we have this plane, they intersect this line over here, and then the third one is going to intersect them both like this, so that the line of intersection of any 2 is parallel to the third plane. Let's see if I can sketch the third one over here. Yeah, so that will be the third case. So line of intersection of any 2. Any 2, we call them pi I and pi j, is parallel to the other one, pi k. So these are the 8 cases that we will encounter, and we want to see some examples of how, when we try to solve systems of equations with 3 unknowns, an equation with 3 unknowns is the Cartesian equation of a plane, we can decide in which of these situations we are. This is the first of our examples, and we will definitely solve it by hand, but you will also try to solve it in the calculator. You should pause the video and do so. And then the result should be that the solution to the system is x equals 1, y equals -2, and z is equal to 4. So what we are saying in this case is that when we try to intersect the planes with the Cartesian equations given here, the intersection is given at one point, and we have a picture of how such a situation would look like. For the second example, you should pause the video and solve it in the calculator, and your solution should be equivalent to the following. I have a parameter lambda for the z coordinate, and then in terms of that parameter lambda, the first coordinate would be minus lambda minus 9 over 3 and 5 times lambda plus 6 over 3 lambda, and this is such that lambda is a real number. So then we have to try to understand what this means geometrically, and it will help to write it in the following way. So we have x that actually we could write as 9 over 3 minus 1/3 times lambda, y that we could write as 6 over 3, so 2 plus 5 over 3 times lambda, and z that is just lambda, and this is with lambda real number. What is this? This is a parametric equation of a line. So we are saying that the three planes from example 2 intersect at the line that goes through the point, let's call it A, which is 9 over 3, that's 3, 2, 0, and has direction vector negative 1 over 3, 5 over 3, 1. So this is the description of the line where the three planes intersect, like in the example we saw before. Now you should try to solve the third of the examples in the calculator. And your calculator will tell you that there is no solution for the system. So we are in one of the cases where we end up not having any point of intersection for the three planes. If you look carefully at the first two equations in our system, you will see that the first plane has a vector normal to it 1, minus 1, 1, while the second one has vector normal to it 2, minus 2, 2. And then the third one has a vector that is not parallel to these two. So we will be in the case where we have one plane, another one that is parallel but not the same. We can see that it's not the same because we don't have 2 times 8 for the right hand side of the second equation, and then we have a third plane that is cutting both of them, but we don't have a point of intersection between the three of them.